Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithm series. In our previous video, we discussed about a well-known example of dynamic problem, that is flower box problem. Now, in flower box problem, selection was made without repetition, meaning if we select one slot, we are not selecting it again. So if we select slot 3, that is the first one, and then if it doesn't fits our requirement, then we move on to next and so on. All right, and then we calculate the optimal height. Now in this video we are going to discuss another well-known problem where selection is allowed, that is called as change making problem. All right, so change making problem. So as the name suggests, the problem statement is we have certain types of coin called denominations, all right, and those denominations are 5 comma 2 comma 12 comma 19. All right, now using as many of each denominations, we want to make certain target value. Now the target, say for example for our case the target is 13. So what can make 13 is 2 comma 2 comma 2 comma 2 comma 5. All right, this will sum up to 13. Now there are some set of rules. So what are the rules? Given the target with the set of denomination, we can use as many coins with repetition as you want, as long as the total doesn't go above the target. All right, and what is the goal? The goal is to minimize the number of coins you need to add up to the target, and if the sum doesn't meet the target, then return -1. So this is the goal. All right, now let's start implementing. So first we will implement a conventional way of dynamic programming using for loop. So that, let's say dev, let's write the method minimum coins. All right, and we will be further optimizing this solution using functional programming approach, using fold left and maybe some other data structures we will see down the line. All right, so let's begin. So we have minimum coins. Now let's, the first value or the input will be the coins itself. All right, which is going to be array of int, and the next value or the another value would be the amount, that is the target. Now it is going to return the optimal number of coins that we need to create this amount, that is the minimum value. All right, so first is we have to create an array to store the minimum number of coins for each amount. All right, so create an array to store the minimum number of coins for each amount. So how we are going to do this? We are going to create a temporary array. Let's do that first. So how it is going to look like? Say it is val dp, and it is going to look like array dot fill. All right, and it will have the value amount plus 1 int dot max value. Now few things to notice here. Why we are using array not a sequence? The reason is, even though this array is a val, but still we can impute the values here. That is the beauty of array. Another thing is why we are using a max val. So we need a placeholder, as in we are using an array with a given length that will be 1 plus the amount, because initially when we start, the optimal result is always 0 with when it comes to dynamic programming, and going forward we increment on that or optimize on that given the set of rules. Now going forward, let's initialize, as we said or as we discussed, the first value of this array as 0. All right, because initially the base case would be 0, that is no coin needed for amount 0. We can say this is no coins needed for amount 0 because there is nothing as of now. Now once we iterate through the amount to the target, so first thing is iterate through the amount from 1 to the target amount. All right, so how it is going to look like, this is the first for loop. So for, and it is going to be I, it will be 1 to the amount. Now it is going to iterate through 1 to amount. Already the 0th position is going to be 0. Now the next iteration, that is we are going to iterate through all the coins, where we are going to do this thing where we are going to select the optimal value. So let's hold on tight. So it is going to iterate through each coin. Now how we are going to do this again? So it is going to be for loop, it is going to be coin, and it is going to be coins. All right, now here we are going to write our logic in this loop. So what it is going to be, the first condition, if I minus coin is greater than equals to 0. All right, so what does it mean? If I have a negative value, then in that case, if I try to search in this DP for this negative value, I will get an error. So we have to handle this. So it is going to be DP and I minus coin is not equal to int dot max value. All right, or if I have these value as max, in these two conditions, so what happens is first value is 0. So first thing is that we are going to check is that the index that we have, it should not be negative. Secondly, the value in that position of that array should not be equal to int dot max. Now if it satisfies both the condition, then we are going to modify or impute the value for that place. So how we are going to do it? Now dpi is equal to maths dot minimum. Now it is going to select dpi and it is going to select dpi minus coin plus 1. Alright, so what happens here? It will select the initial position for which we are modifying, and it will also go back one step and see what is the optimal value that we have, and if we find anything, we will be incrementing it with 1. If it is 0, then it will be 1 ideally. So initially it will start with 1. Now here, as we see that it is updating, so there is no else needed because we are using for, and this is why I called it as an imperative way or a common way of doing it, where we are using multiple for loops and inside that we are defining if. Now this is a valid if statement, but if we are using something other than this like fold left, we need to define else as well. That will safeguard for any corner cases. All right, now if, so what we need to do is, we this will be calculating the amount that we need or the optimal value, but how we will know which one is it? So in dynamic programming, as we are optimizing on the sequence, now at the end or the last value is always what we need. So we want to do is, if the dp amount equals to int dot max value, if it is so, it means we haven't found our match, then it is going to return -1, else it is going to return dp of that amount. So it is going to fetch the value in that index where the last element is the amount. So amount is going to be 13. Now that is the reason why I selected an array amount plus 1, because the array will start from the index 0 and it will go till amount, and amount plus 1, this value. So this amount is 13. So the last value here would be the value that we would be interested in, and that is what we are going to get. All right. Now let's see, print this solution and let's see whether we have achieved our result or not. So let's print this. and let's pass this value. So let's name it as val coins is equal to array of 5 comma 2 comma 12 comma 19, and let's say val target is equal to 30. Now we are expecting that the result that we are going to get is 5 amount. All right, so we have both the values, coin and amount. Okay, this is going to be target. All right, now we are expecting that we will have a value that the maximum coins, that is the length 1 2 3 4 5. All right, let's run this. Before that, let's comment out what we have earlier. All right, let's run this and let's see whether we meet our goals or not. All right, so quick recap. So what happens here, this is the logic for dynamic programming. We already initialized an array, and as we traverse from one coin to another, we are just scoring on and optimizing the value on each index. This is the logic, so that coin should not be less than 0. And yes, finally we have achieved 5, which is the expected value. You can experiment this with multiple set of coins and the target value, and it is going to give the optimal result. So this is a very imperative way of writing dynamic problem solution for the minimum coins. Now in the next video we are going to discuss about how we can write the same problem using a fold left. We will also try to see if we can improvise on this array, because we have used this initial array. Now there could be a solution that where we don't need to have this array, we can do this using a sequence. Yes, it is possible. We will also see that down the line, and we will also see if we can use an alternative to an array, that we can have a map where we have the get and put. The time complexity for get and put is 0 to 1, so it is quite efficient than an array, but for a small value like this it will be almost same. All right, so if you enjoyed this video, please like and subscribe, and see you in the next video. Thank you.